Now, the rate of transpiration, if you look at the definition of transpiration, is the loss of the water vapor from the plants through the to the surrounding down the water potential gradient. But the direct measurements here, the direct measurements of the rate of transpiration is difficult. Okay, how you measure the water vapor? You cannot measure the volume water vapor because they are in the gaseous form. Correct or not? So, but it's much more easier for us to measure the rate at which plant stem take up the water. But again, here we have to understand that it's not every single water molecule that taken up by the plants will be used for the transpirations. But we do know that almost 99%. So that 1% for the hydrolysis, 1% for the photosynthesis, 1% for the turgor pressure, those is we can neglect it, okay, with assumptions here, very important assumptions, okay. So what is the assumption in this experiment? With assumptions, okay, if you want to get the true rate is impossible, we only can get the approximate rate of the transpirations. With assumptions, the rate of the water uptake equal to the rate of transpiration, which is not really true, but we do know that majority, high proportions of the water taken up by the plants will be used for the transpiration. So how we set up this? So the setting out of the potometer, you need to understand that because we do not want to have any airlock in the pipes, a tubular structure here. So therefore, you need to cut the plants under the water. You need to cut the plant under the water and set up the entire potometer under the water. So first of all, what we're going to do, we are going to select a healthy leaf, okay, leafy plant, and then we cut it at the stem here and insert this into the potometer, and we introduce in this what we call the air-water meniscus. Are you clear? So once we have done the setting, we can take it out and then we place up. For example, you want to see the rate of the transpiration, then we do the timing. Let's say in 1 hour, what is the movement? Are you clear? What is the movement? And we always can measure the diameter of the capillary tubes, correct or not? And then we can get the volume. Okay, so try to answer these questions. 2 minutes. So let us look at the answer. So first, what we need to do, we need to choose a healthy leafy shoots and cut it under the water. We cut these shoots under the water. And next, what we're going to do here is the shoot is inserted into the potometer under the water to avoid the air bubble traps. Okay, we don't want to have the airlock in the xylem vessel, which is going to slow down the transpiration process. Okay, so next you apply the Vaseline or petroleum jelly, okay, to the rubber tubings to make sure that the apparatus is airtight. You make sure that it's airtight because we don't want to have any loose in the pressure, then you won't be able to measure the rate of transpirations. And next, so as the shoot takes up the water, the air-water meniscus in the capillary tube move up as well. These meniscus will move. And then what we're going to do here is the positions of the meniscus is recorded at a set time interval. If you want to know, okay, every minute, for example, every 10 minutes, you can actually record it down. Okay, then we can plot the graph. Okay, the graph or the distance move against the time is plotted to obtain the rate of the water uptake. But the thing here is, guys, you only measure the rate of water uptake. But if you want to get the transpiration rate, you need to do the assumptions here. The rate of water uptake is assumed to be the same as the rate of the transpiration. So answer PUVQRST. Okay. So let us look at how we can calculate the rate of transpirations. Okay. So it's useful to be able to measure the rate of transpiration per unit leaf area. So not only, guys, not only the how much water vapor loss, but also we want to see per unit area of the leaf, because the larger the leaf area, it may contribute to this rate of transpiration. So this allowed a valid comparison to be made between the different species, different plants of the same species, or different leaf of the same plant. So in order to do this, leaf must be measured, the leaf area. So the outline of the leaf is drawn on the graph paper with 2.0 mm spacing as shown in figure 8.8. Okay, so can you calculate the total surface area? Okay, so how we calculate? Now let us look at this. Okay, enlarge this part, then you can see that. Now first we do count how many boxes. Okay, so first you look at this, we have 3 boxes. Here we have 15, 16, 17, 18. So this one we have 22. This one we have 20. This one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Please correct me if I'm wrong. So this one we have, okay, you total up first, guys. 14. This one we have 1. So this one 25, 25, 25. So this one we have 4. This one 25. This one 23. How many total up, guys? 16, 5, 9, 1. Okay, so now you can total up. Okay, can you guys help me to calculate, guys? Okay, so what is the total surface area of the leaf? So total surface of the leaf. Oh, sorry. The leaf. So equal to, now I need a times 2 because upper and lower, correct? Upper and lower. Okay, so 2. So how many boxes? How many square? 248 square. And the area of each square is 2 mm by 2 mm. So can you get the area now correctly? Can you see that? 248 squares. So each square is 2 mm by 2 mm. So that's why we multiply by 2 mm by 2 mm. We multiply 2 because of the upper and lower epidermis. Okay, the transpiration can take place at the upper and lower layer. Okay, so 248 multiply with 4 multiply with 2. So answer 1984 mm square. Okay, this is the total surface area of the leaf. So 1984 millimeter square. Correct or not, guys? Okay, good. Okay, I have some of you guys give me the answer. Very good. 1984, you guys correct. Okay. Now the diameter of the lumens of the capillary tubing is 4 mm. Okay, the total distance moved by the air-water meniscus is 25 cm in 30 minutes. So guys, 25 cm we need to change, minute we change it to hour per hour. Okay, so it means that we write down the distance moved equal to 250. Okay, or you guys need to do this, sorry, 25 cm, right? So 25 multiplied with 10, so they change to mm. So equal to 250 mm. So time taken, so equal to 30 minutes. So 30 divided by 60, change to hour. So equal to 0.5 hour. Okay. So what is the volume of the, volume of the water? So volume actually pi r. So r is a diameter divided pi r square multiplied with the distance. So pi is 3.14. Diameter, we have the 4.0 divided by 2 square. Distance moved is 250 mm. So calculate, you get the volume of the water uptake. Okay, 3 significant figure, 3.14 multiply with 4 divided by 2 square, multiply with 250. So 3140 mm cube. 3140 mm cube. So if you want to calculate rate of water uptake per unit lift, so rate of water uptake per unit lift area will equal to the rate of water uptake. So rate of water uptake is 3140 divided by time, 0.5. This is the rate of water uptake divided by the lift area. So lift area just now we have 1984. So calculate, you get the answer. So 3140 divided by 0.5 and divided by 1984. So 3 significant figure, 3.17. Okay, 3.17. Now the question here is, what is the unit? Okay, can you guys suggest a unit for me? So rate of water uptake per unit lift area. Okay, so you get this. So what's this, guys? So why I divided by 0.5? So this is the rate of water uptake by the plant. This one actually is the surface area, okay, of the lift. Okay, so some of you actually suggested the unit is millimeter per hour. Guys, millimeter is not the volume. Can I see that? So generally, we cannot use the idea of the mathematics, okay, where we go and cancel, because the unit won't give us the meaning. So the correct unit here is, if you look at this, for the rate, so the rate will be per, it's a mm cube per hour. This is correct, mm cube per hour. And then, because we're the rate per unit area. So if you want the rate per unit area, it becomes millimeter cube per hour per mm square of the lift surface area. So the answer here is the unit. How to put a unit? So the unit actually equal to 3.17 mm cube per hour per mm square of lift surface area. Then there is a meaning. What's the meaning? So it means that for every mm square of the lift surface area, the plant are going to lose 3.17 millimeter cube of the water per hour. Are you clear? So answer here is 3.17 millimeter cube per hour per mm square of the lift surface area, not mm per hour. If mm per hour, then it won't show us the volume. Are you clear? So you cannot use a mathematic way when you give the unit. So now with the assumption saying that, the rate of the water uptake equal to the rate of transpirations. So therefore, the rate of transpirations equal to 3.17 millimeter square per hour per mm square of lift surface area. Okay, so with this, I have done for the rate of transpirations, how we measure and calculate the rate of transpiration.